Hello. Welcome to the test review homework help video. Here we go. There we go. Okay. Given the graph, identify the domain, range, max, min, increasing interval, decreasing interval, constant interval. So many things. We can do it. All right, I'm going to insert a text box. Oh, it's not going to go where I want it to. Hold on. There we go. Boop. Boop. Move this guy over here. And up there. Okay, so first things first, we'll do domain. Domain is looking at your x values, left to right, looking at your x values. You're going to write it using your x values. Okay, so my lowest x value, my x value furthest to the left is -3. And it's a point on the graph, it's filled in. And then we have a continuous line, no breaks, no jumps, all the way to x equals 4. That's your domain. It's the x values. X equals -3, and our graph goes all the way to x equals 4. All right, range. Oh, here, let me do a different color. You know how I am with my colors. Okay, range. Now you're looking at the y values. So we're looking up and down. We're looking at the y values. So what's the lowest point on my graph? The lowest y value, -1. And it's filled in, it's on my graph, -1. If there was an open circle there, then you would use a parenthesis. All right. And then it goes, now we're looking up and down. So my highest one is 4. Another bracket. Once again, if this was an open circle, you would use a parenthesis, but it's not, so bracket. Maximum and minimum, you're focused on y values. What's the highest point on your graph? So my highest point is right here. So you can either write it as a point. The point is -3. Or you can say max is 4, when x equals. Okay. Minimum, lowest point on your graph. I'm giving you a second to look and find it. Okay. It's right there. Boop. Lowest y value is -1, so you can write it as a point. My minimum point is x equals 1, y equals -1, or you can write min is -1 when x equals 1. Okay, max and minimum. Increasing. Where are we increasing? This isn't the one we did in class, is it? No. I hope not. Okay. No. Is it? Hold on. Oh, there's no easy way for me to look at it. You're gonna see my desktop. Oh, no, that's my internet. Maybe I don't have it on here. Oh, here it is. Okay, good. Oh yeah, we did that one. All right, we're good. Sorry. Moment of at a lapse there. We're good. Increasing interval. So where is it increasing? You are going to be looking at the x values. From where to where is it increasing? Let's see. Okay, here's my increasing, and that's x is equal to 1. And it increases from 1 to x equals 2. So you're focused on your x values. Decreasing. Where are we decreasing? Well, I'm going to let you find it. Okay, we're decreasing here. And so we're looking at our x values. So from x equals -3 all the way to x equals 1. I won't mark it wrong. You can do a bracket, or technically, I think it should be a parenthesis. Technically, it should be a parenthesis because then when you hit 1, you start increasing. But for that, I won't mark off for that one. So if you do parenthesis, cool. If you do a bracket, that's fine. Okay. What else? Oh, constant. Where is it constant? That means it's neither decreasing or increasing. Yeah, from 2 to 4. 2 to 4. Where's my back? Yeah, there we go. From x equals 2 all the way to 4. Cool beans. Okay. In the graph above, how many x-intercepts are there? In the graph above, how many x-intercepts are there? So how many times does it touch or cross the x-axis? 2. Right there and right there. So it doesn't ask you to write them, it just says how many times. So there are 2 of them. Oh, I lost my color. How many y-intercepts? How many times does it cross the y-axis? Only right there. 1. Oh, every time. 1. Okay. Moving right along. Okay. You do not have this. I just cheated and put this in because, yeah. This morning was painful. This will still be painful, but hopefully a little bit less painful. So it says, giving the following features of a function, sketch a possible graph. So I like to focus on pulling out the domain, the max, and the min first. And then you can draw in your intervals however you need to fill that space. So my domain is -4 to 8. So -4, boop, right there. X equals -4 all the way to x equals 8. Okay, and there's a parenthesis. So that means there's going to be an open circle where x is equal to -4. And then there's a bracket, so it's going to be closed at x equals 8. Okay, so we're going from here, -4 to 8, and then my minimum is 1. So that means I'm not going to have anything on the x-axis. My minimum is 1. Nothing will be touching the x-axis because nothing goes lower than y equals 1. And then we have a maximum of 6, so nothing will go higher than 6. All right, so we're working between y equals 1 and y equals 6, and we're working between x equals -8, sorry, x equals -4 to 8. Okay, so knowing that, well, we have a open circle at x equals -4, so let me just throw that in there, the circle. I mean, I could use an oval, I guess, same thing. Is there not a circle? Oh, look, there's the circle down here. Okay, so, but I can't put it right on the axis because our minimum is 1, so I'll put it right here. Maybe. That was not good. Let me try it again. Bam. Oh, I lost it. My bad. Insert -4. Okay, let's make it black. Make it so I can move it around everywhere. Okay, click off it. Yeah, that's a -4 and 1. I'll take that. Okay. And then, let's see, I cannot go any higher than 6, and I cannot go any lower than this dot, which is at y equals 1, because that's our minimum. So let me insert shapes. Let's do a line. So we're increasing twice and decreasing twice. Okay, well, I can't go any lower than this, so I may as well increase first. We'll increase to there. And then we'll insert another line. So we're increasing, and now we'll decrease to oh, I said the circle had to be open on -4. I'll go fix that. We'll decrease to there. Okay, we'll decrease to there. As long as we're not getting lower than y = 1, we're good. And then we'll insert another line. So we have to make it all the way to 8, but we can't go past x = 8. This is a really small. Okay, we'll go all the way up to our maximum, which is 6. And then we'll insert another line. Oh, not that. Insert another line. There it is. And then we'll, did I do it? Insert shapes. I thought I did it. Line. Then we'll insert, or do I actually maybe because I didn't click off it. Oh no, there we go. And we have to make it all the way to 8. So we'll just extend on out. To 8. Okay. Pretend these are all touching. Let's see if I can make them touch. Probably not. Probably not that good. Oh! Aha! Okay, that's not above 6. Okay, let's see if I can extend this guy and touch this guy. Okay, but then this circle has to be open. So, there we go. So I have an open circle at -4 because I have a parenthesis, and then if you can leave it like that because it's not an open circle, so 8 is on the graph. If it makes you feel better, you can put a closed circle on it. Is that even close? It's so cute, but there you go. So that's one example of a graph. Remember, it does not have to look exactly like mine. It has to be a continuous line. There should be no, well, yeah, it has to be a continuous line. There are no breaks or jumps in your graph. Yeah. I mean, there are ways you can make it discontinuous, but why? Yeah, I wouldn't bother with that. Make it continuous. Stay within your domain and make sure it's marked. So -4, I have an open circle. 8 is closed. And make sure you stay within your range. So I didn't go any lower than y = 1, and I didn't go any higher than 6. And then make sure you have your intervals right. So I have 2 where it's decreasing, and I have 2 where it's increasing. I'm increasing here and here. I'm decreasing here and there. So that's one example of the graph. Okay. See, that was less painful than this morning. Okay, find the intersection point between f of x and g of x using the algebraic method. It's going to be on the test, and it's going to ask you to show your work. Well, I mean, you're going to have to show your work. Okay, so your first step, not table, sorry. I'm used to doing a table. We'll do insert text box. So, step 1, set equal to each other. Step 2, solve for x. Step 3, substitute x value in for y in either. Boop, boop, boop. Okay. So your first step is to set them equal. Hold on, let me get rid of my spacing. Okay, there we go. So 3x plus 15 equals -5x plus 31. Okay, now we're solving for x. So now I have to get all my x values on one side and all my regular numbers on the other side of the equal sign. So I don't like dealing with negatives, so let's just get rid of it. So I'm going to add 5x to both sides. If I add 5x over here, I have to also add it over here. 3x plus 5x is 8x. And then we didn't do anything to the 15, so just rewrite it. We're doing one step at a time. Negative 5x plus 5x, 0. So all that's left on this side is 31. Okay. Now, I want to get x by itself. So this 15 is in the wrong spot. So I'm going to subtract 15. And then I must subtract 15 over here as well. I'm wondering if I did this problem correctly. Yeah, I did. Okay. 8x. And then we didn't do anything to 8x, so I just rewrote him. 15 minus 15 is 0. And then on the other side, you have 31 minus 15, which is 16. Last step. This is saying 8 times x equals 16. So you can do, some of you can probably do this mentally. 8 times what number equals 16? That's 2. But what we're doing is we're dividing both sides by 8. So 8 divided by 8 is 1x, which is just x. And then 16 divided by 8 is 2. Okay. All right, so now you're only halfway done though. Now we know x equals 2. Here. Okay, so now my last step is to substitute the x value in either equation. So I'm going to take 2 and I'm going to substitute it in for x in either equation. It doesn't matter. This is where they're equal to each other, so you'll get the same thing. I'm going to do f of x. So actually, maybe I'll do both just to prove it to you. So I'll do f of 2, substituting in 2 for x. So now I have 3. Oh, 3. I'm multiplying it by 2 plus 15. So that's equal to 3 times 2 is 6 plus 15 equals 21. Right? Yeah. So then y would equal 21. So my answer, I'll write right here, is going to be 2, 21. Green and highlight it. That's the answer. 2, 21. Okay, but then if I were to substitute it, I'm just going to prove this to you. You only have to pick one. I'm going to do both. I'm going to substitute it in for g of x. So I'm substituting in 2 equals negative 5 times 2 plus 31. Equals negative 5 times 2, negative 10, plus 31 equals. Okay, so you get the same thing because they're equal to each other at that point. All right. I'm going to get rid of that because it'll confuse other people. There you go. Okay. Perfect. So that one's done. That's our intersection point, 2, 21. Is the following a function? Why or why not? All right, well, I'm going to let you look at it. I'll shut up for a second. Okay. Well, a function, every x value, remember x values have to be exclusive. So every x value can only have one y value. Y values can do whatever they want, but every x value can only have one y value. So let's see, I have 2 and 6, 3 and 5, 2 and negative 2. Oh, red flag. X equals 2, y equals 6. X equals 2, y equals negative 2. That is not a function. Not a function. I have when x, I should do it in a different color. When x equals 2, y equals 6 and negative 2. That is not a function. That is not a function. So we're going to write no, because x equals 2 has 2 different. Okay, so that is not a function. When x equals 2, it's y is 6. X's have to be exclusive. It cannot have another y value related to it. Nope. Nope. Okay, so no, it is not a function. Every x value has to be related to only one y value. But the x values can have the same y values. So like, what if this was, oh, it's still not going to be a function. Hold on. What if this was 5? And this was 1. Okay. Now it's a function. Each x value is related to one y value only. 3 and 7 have the same y value, but that's fine. The y values can do whatever they want. As long as one x value is related to only one y value, then we're good. Okay, let me change all this back. I didn't know I didn't finish typing that. Okay. Is following a function? Why or why not? No. I mean, for me, whenever I have a graph, I always use the vertical line test. So if I were to use a straight line, it would intersect my graph at 2 points. So it fails the vertical line test because it fails the vertical line test, which means that x values have more than one y value. That's fine. You can put it like that. You could be using different vocabulary. Like you could be saying no because some inputs have more than one output. However, but just explain it in a way that makes sense to you. But you need to give an explanation. You can't just say no. Because then I'll just assume you guess, so you won't get full credit. Is this the last one? Oh, is the following a function? Why or why not? Okay, well, all my x values are different. -2, 0, 3, 4. If all of your x values are different, it's a function. Because they're all just related to one y value. I don't have any repeated x values, so it is a function. Yes, because all of my inputs only have one output. Or yes, because all of my x's only have one y, or whatever, something like that. Whatever it means, you can say it in your own words. But make sure you give me an explanation. Ta-da! Okay, that's it. That was fairly painless. Let me stop the video. Goodbye and good luck.